My name is Kiara Parker, and this is my research on metric proficiency in scientific literacy. This research focuses on age, gender, country of education, and highest degree received using a 24-question survey and analyzed using RStudio to determine the factors that affect metric proficiency, scientific literacy, and attitude. Science and math are core parts of the learning curriculum in grade school. This provides an exposure to mathematic and scientific principles and concepts. However, this exposure reduces drastically upon entrance to college, and even in some cases if a student is a science major. Many biology undergraduates at four-year institutions have very few requirements that utilize or are relevant to math. When they do involve math, the courses use non-biological examples and abstractions. Because students are not exposed to any examples that correlate the need of math to biology, this only compounds the lack of appreciation of science. As a result, understanding factors that affect scientific attitude is actually a growing concern within the scientific community. This makes understanding what affects scientific attitude rather important. Also, if a student doesn't have a particularly positive scientific attitude, it would be important to know if and how that would affect how students perform in solving metric conversions in scientific literacy questions. The question still remains, why would the research include those that are not science majors or not specialists in math and science fields? Scientific literacy is simple mathematics and basic science concepts that are used in everyday life. Everyone is exposed to some level of science, such as in the news and in our physical environment, and because everyone should understand what's going on around them, it becomes important to see if the general population does in fact exhibit scientific literacy, and if not, determine what in fact affects this. To reiterate, scientific literacy is a term to address scientific knowledge based on how the average person actually uses science. It's the knowledge to address daily common issues, and the information that falls under the spectrum is broad but not in depth. For example, a person who is scientifically literate should know essential and basic concepts and vocabulary related to matter of energy, forces, and motion, which include but are not limited to the nature of atoms, the Earth's cycle, basic concepts of cells, as well as evolution. A specific component of scientific literacy called metric conversion involves the use of simple math to convert a numerical value into its proper scientific unit, such as converting miles to kilometers or inches to centimeters. Even though metric units are considered the proper unit of measurement within the scientific community and is used as a major unit everywhere outside of US, Burma, and Liberia, it is still not frequently used within the United States when compared to the rest of the world. Because metric conversion is needed in even the most standard science, and yet daily exposure to metric conversions is limited, it is hypothesized that metric conversion is directly related to a country a person was educated in. Scientific attitude is often characterized by a list of components including objectivity, open-mindedness, the willing to suspend judgment and personal beliefs when presented with sufficient and valid evidence, as well as having a general positive attitude towards science. As I mentioned before, scientific attitude has been a growing concern within the scientific community, and over the years, science educators have developed a unanimous want to include the development of scientific attitude among the general goals in scientific instructions. For example, developing the appreciation for and the ability to use the scientific method. The data collected in this research came from online and in-person resources of over 200 participants. Participants were given a 24-question survey. This survey included 4 questions about the background of the participants, including the age group that they belong in, the gender, the highest level of education, and the country of education, which were observed separately as factors and compared to scientific attitude, literacy, and metric conversion. The survey included 5 questions for metric proficiency, 5 questions for scientific attitude, and 9 questions for scientific literacy. Using RStudio, the average accuracy of each factor, such as age, was compared within each group of questions. An example of the type of questions that fell under each category is listed below. Here we see a box plot of gender on the x-axis and percentage of accuracy on the y-axis, which is indicated by how many questions out of 5 or how many questions out of 10 the person got correct. In both figures, we see that male participants answered with a higher accuracy in regards to both types of questions. When observing scientific attitude relative to gender, we can see that men also display a greater positive scientific attitude compared to women. Because men displayed a more positive attitude and higher accuracy, this data supports that scientific attitude is directly related to scientific literacy. However, we cannot say that men display a greater scientific literacy than women, because analysis of the survey population revealed that male participants have a significantly higher average age rate of about 40 years old than women of about age 20. As a result, analysis of gender within age was analyzed. Here we see a box plot of scientific literacy and age compared for male and female, where the average age within each age group is displayed on the x-axis and the percent accuracy out of 9 questions were displayed on the y-axis. We can immediately see that when age is controlled, gender shows a drastic decrease in difference of accuracy. Here we can see that in scientific literacy, females show the highest rate of accuracy between ages 23 and 50. Age group 51 through 55 have the lowest average, and age group 18 through 22 and 65 and older lie as a median between the two results. Scientific literacy among men show a general high average rate of accuracy than women. However, both men and women have the youngest age group with a relatively low accuracy. Age group 31 through 55 have the highest average of accuracy, with age group 31 and 50 to 55 being the highest. With metric analysis, we see that female have the age group 31 through 40 having the highest accuracy, with age group 41 through 50 and 65 and older having the second highest average. Again, age group 51 and 55 has the lowest accuracy. This is somewhat similar to the results of male participants. Males show a middle age and older age group having highest accuracy. However, here the lowest percentage of accuracy lies within age group 18 through 30 and age group 23 through 30. This evidence seems to indicate that there is a correlation between scientific literacy in general and translating to greater metric proficiency. Results of scientific attitude within context of age for women reveal a high positive attitude for age group 56 through 60, and all other age groups except the youngest age group 18 through 22 showing equal or insignificant difference in mean. Similar to men who show a high percentage of accuracy among middle age and older age groups, with the difference of course being that age group 23 through 30 have a drastically lower scientific attitude than all other groups. Because there was no significant difference among women within scientific attitude, and there was in accuracy, and because male participants of age group 31 through 40 performed with highest accuracy but displayed lowest scientific attitude, evidence suggests that scientific attitude does not affect ability to answer basic science or metric conversion questions. Box plot of average age within each group is displayed on x-axis, and accuracy out of 5 questions are displayed on y-axis. Within scientific literacy, there is an overlap of average percent accuracy. Highest mean are between middle age groups of 31 and 55, with age groups 65 and older having close to similar accuracy. Metric analysis shows similar trend, with the young age group having lowest percent accuracy. The middle-aged and older age groups have relatively high accuracy in both scientific literacy and metric proficiency. However, there is a significant decrease in accuracy of overall scientific literacy and metric conversion within age groups of 23 through 30. Older age groups 53 and 30, 53 and older have high scientific attitude. Age group 18 through 22 showed lowest scientific attitude overall. Comparison of metric analysis in scientific literacy and scientific attitude within context of age. Here we have a box plot of the highest level of education in percent accuracy out of 5 or 10 questions. Here we see a strong association between those with higher education, specifically those with master's, PhD, or MD, in accuracy of answers. Additionally, it's important to note that those with bachelor's of science perform better in accuracy than those with bachelor's of art. Results in scientific attitude show that MD has the highest scientific attitude, with all answering true to every question. All other educations have similar results, with Master and PhD having slightly higher average. With these results, we can determine that participants with higher education have a more positive attitude than all others. Those with higher education have a higher percent accuracy, PhD being the highest accuracy, and those with an undergraduate degree in science have a higher scientific literacy than those in arts. Participants educated from anywhere but the U.S. were placed in one category marked as 0 on the x-axis. Participants educated in the U.S. are marked as 1. It's immediately clear that those educated from anywhere but the U.S. have a higher percentage of accuracy with metric conversion and slightly but significantly higher in scientific literacy than those who were educated in the U.S. However, mean of scientific attitude between those educated in the U.S. and outside of the U.S. have no significant difference. This is indicated by the p-value. Although there is no evidence of a relationship between the scientific attitude and the accuracy of answers, these results cannot state definitively that scientific attitude does not affect the metric and scientific proficiency because of other factors that can affect the higher percentage of accuracy, mainly the increase of exposure to the metric system in everyday life. Next, we see a plot specifically for the scientific attitude and the scientific literacy, regardless of all other factors. Here we see a very clear relationship between the two. The box plot of the relationship with accuracy out of 9 questions specifically related to scientific literacy are displayed on the y-axis, and those with high and low scientific attitudes are marked as 1 and 2 on the x-axis respectively. The results reveal a strong positive correlation between scientific attitude and scientific literacy, and it can now be concluded that those with high scientific attitude have high scientific literacy. Just to quickly review what each factor revealed, we can determine that there can be no conclusion stated between the relationship of gender and scientific literacy because there are other factors, especially age, that affect these results. From results addressing age alone, we can identify that younger age groups display lower scientific literacy and metric proficiency, and middle-aged and older age groups display higher scientific attitude. Results of analysis of highest degree prove a clear correlation between education and scientific literacy and attitude. It can be concluded that the higher the education, the higher the accuracy, and the higher the attitude. Additionally, we can conclude with consideration of undergraduate degrees that those pursuing science are more scientifically literate, however they do not exhibit greater scientific attitude. Observation of country of education reveal that country of education does not affect scientific attitude, however those educated outside of the U.S. display higher accuracy in metric conversion and scientific literacy. From analysis of scientific literacy and attitude, it can be concluded that there is a positive relationship between scientific literacy and attitude. This research gives a descriptive analysis of data generated and observes a wide range of factors. However, when observing over a large range of factors, there must be a consideration of overlap of influence. Although this research does take some consideration of overlap, such as making specific observations of gender with age controlled and the relationship between scientific literacy and attitude, there are other factors that could influence results. Suggested further research includes observation of what factors affect comfortability with attempting questions of metric conversion and basic scientific concepts, as well as determine if metric conversions in scientific literacy is related to career field or solely the highest degree received. Additionally, this research determines that those educated outside of the U.S. have higher metric proficiency. But factors that affect metric proficiency specifically outside of the U.S. has yet to be observed. My name is Kiara Parker, and I thank you for your time and attention.